Hi, in this video we want to discuss the new camera APIs that are available in iOS 7. The API features increased security for audio and camera capture in various markets, and we'll talk about that a little bit in passing. 60 frame per second video capture across the board that supports editing and so forth all throughout the iOS 7 APIs. Zoom we can now apply to video instead of just still captures, still pictures. Barcode detection has been added. There have been enhancements to focusing and focus detection, and the camera API now integrates with the application audio session to enable audio capture along with video as well. Now, of these 6 things, we're really going to spend the demo time focusing on our 60 frame per second video capture and the barcode detection APIs. Everything, of course, can be looked up, and there is a very nice discussion in the WWDC presentations available on developer.apple.com, and there are also in the documentation, both within Xcode and also on developer.apple.com, there are extensive documentation for all of these new APIs as well. So let's talk about the enhanced security. This is put into place because in various markets there are some restrictions on what you can capture and when you can capture microphone or video data. And in those markets, the restriction basically says you must inform the user, and in some markets you must also inform the target, in other words, who you're capturing when you are recording. So a new dialog has popped up. In all markets, the microphone capture is very sensitive information. So a new dialog has popped up in all markets when an app attempts to use the microphone. However, in some markets, a similar dialog will be popped up when an app tries to use the camera. Now, these dialogs come up the first time that the user, or the app, tries to use the microphone or the camera. When the user responds to the dialogue in a positive manner, in other words, the user is going to allow these devices to be used in the app, then everything is okay and video or audio begins to record. But the API, the camera API, has to come up before the user responds. So until the user responds positively, either silent audio or blank or black video frames are recorded until the user responds positively. If the user responds negatively, then that is all true, but the camera API will be dismissed. So what happens then in subsequent attempts when the app tries to create an AV capture device input after it's been denied? Well, there's going to be an error. And that error is AV error application is not authorized to use device. So we need to look for that error now because of these more restrictive secure dialogues that the user has presented. So now some high points on the 60 frame per second video capture. We will have a demo on this, but I'm only spending one slide here. It supports 60 frame per second all the way up to 720p resolution. It will allow playback at a slower or faster speed without altering the pitch of the audio if we desire to do that. Of course, we can still play back faster, raising the pitch of the audio as it would normally do, or play back slower, lowering the pitch of the audio. But if we desire to retain the pitch, then we can have audio playback during faster or slower video playback without altering that pitch at all. It fully supports editing of mutable video captures. In other words, if we have captured the video and it is in a mutable format, we can edit that at 60 frames per second. We can also choose only certain sections of the video to speed up or slow down, and then that information will be preserved when we export the file. Now, what about barcode detection? This one is pretty big. It is new to iOS 7. It uses and leverages the existing AV Capture metadata output class, which was previously only used for face recognition. However, now this class also supports various metadata types, which include 1D and 2D barcode formats in a lot of different ways. So the process for programming this is to allocate in it an AV Capture metadata output object. And of course, we already have a capture session, so we make the output object, the metadata output object, we add it as an object. We call the add object method of the AV Capture session and pass in the object, the AV Capture metadata object, or AV Capture metadata output object that we just created to that add output method. Then we set the delegate, and the delegate is called AV Capture metadata output objects delegate. This is the delegate that will be used to capture the actual information about the barcode that will be used by your application. Then we need to set up an array of barcode types that should be read. Previously, AV Capture metadata output only captured one type of metadata, so it was not required to set up an array of types because there was only face recognition type. Now, of course, we have several different barcode types added to that. So we don't want to get them all because that would add CPU cycles. It is CPU intensive and therefore potentially battery wasting to do so. So we don't want to get them all. We just specify these certain types of barcode that we should read with our app. Then we take that array and pass it to AV Capture metadata output object as the as the parameter of the set metadata output types method of that object. So now, how do we get that data back? Well, in the delegate that we set up, in the AV Capture delegate, we want to implement capture output, did output metadata objects from connection. The output we get in this delegate is the AV Capture metadata object, object. And then the second, the output metadata objects, is the array of the actually captured objects. So we may have more than one here. And then the third is the AV Capture connection object that we already had. Now, so we can use this information. Most importantly, we can use the array of the objects that were actually captured. This delegate method is going to be called anytime a metadata output is captured into with the camera. So now we want to check to see that each of these outputs is of kind of class AV metadata machine readable code object. And if it is, we want to do something with the barcode data. If it's not, it's face recognition data. So we can do something with that as well. Now, how do we decode it? Well, that AV metadata machine readable code object that we get back in the array of captured objects has four important, and these are all read-only parameters or properties. It has a bounds, which is the rectangular bounds of the entire capture, and it also has an array of CG points that specifies the corners of the actual captured object. Think about it. If the user holds the camera perfectly still, perfectly orthogonal or parallel to the barcode that they're trying to capture, then everything is okay, and the bounds, the corners will be the corners of the bounds. However, usually what you have is the camera at a slight tilt or off axis by a little bit, and so that bounding box will not be the actual bounds. You can get a better bounding box if you use the corners and normalize them into a rectangular area. The type is an inner string, which is the type of corresponding with a barcode type. For example, code 39 or QR as you see in magazine articles, or Aztec barcodes can all be supported. And there are various other ones that can be supported. The types are string constants, so use the constant name rather than the actual string. So we can compare to see what kind of barcode it was. And then, lastly, and probably most importantly, is the string value, which is the best effort to decode the barcode data. Now, if that barcode data is degraded in some way, if the barcode itself is physically unreadable, this is going to return a nil if it fails to decode it. So you can check that value, potentially ask the user to try to scan the barcode again, hoping for real data, or if they try it twice or 3 times, you can just throw that away and say, I can't do anything with this barcode. But string value of nil is something to check for in your application to make sure that you have good data. Once you have the data in a string, then you can present it as you can slice and dice it any way you want to. Present it as you will. All right, so we're going to have a demo on 60 frame per second video capture and what you can do with that, and also a demo on barcode capture. Thank you very much.